So, question 1, I had already done a few of these problems, but I'm going back and redoing them as I realized they did not have audio. So question 1 is you want to start saving for your daughter's college education now. She will enter college at 18 and will pay fees of $4,000 at the end of each year. You will start your savings by making a deposit in 1 year and at the end of every year until she begins. If annual deposits of $2,458.79 from today onward at the end of each year will allow you to reach your goal, how old is your daughter now? And assume you have 6% annual interest on your savings. So, for the first step, we are going to put in our FV value as 0, as you want it to be nothing. You don't want to owe anything. Our PMT is that negative 4,000 of the fees. And then, as we said, the rate will remain 6% annual interest rate. And the number of periods, so at the end of each 4 years, so 4 periods. So now we want to calculate what is the initial value that would be necessary. So we're going to use the PV equation. I'm going to plug in a 6% interest rate for 4 periods with $4,000 payments, and that number is negative as you are paying it. So we are looking at this as the side of you are the parent, so you are going to be, quote unquote, losing $4,000 for a final value of 0. With that, we get $13,860.42. So now the second part of this question is, well, how old will she be? And so we're going to look. So we now have our PV value, which is 0. Our FV value, so our final value, is this PV number. So $13,860.42. Our rate will remain the same at 6%. And our PMT changes because annual deposits of $2,458.79. So we're going to put in negative $2,458.79. And now we're going to calculate number of periods, because how many periods would it take to get your daughter to the age of 18? So we're basically calculating how many years. So equals, and per. So 6% rate, payments of that 2,000 number, initial value of 0 for a final value of this amount, 4.999. Okay, so about 5 periods. So 18 minus 5 equals 13. So she would be 13 years old, so just turned 13 years old. Question 2. You want to buy an Audi A8 on your birthday. The car currently costs $83,800 and will appreciate by 10% per year until you're ready to buy. You can invest to earn 10% annually. If you've just turned 20 years old, how much must you invest per year to be able to purchase the Audi in 7 years? So the first step is we're going to be calculating how much will that Audi be when you are ready to purchase it. So the PV is that negative $83,800, as that's what it would cost if you were to buy it today. And the rate, it appreciates at 10%. And the number of periods, don't know why that's in red. The number of periods that you would be looking at is 7, because it would take you 7 years. So now we're going to calculate the final value. So what would it cost in 7 years? So equals FV, rate of 10%, 7 periods. We're going to skip over payment because you would be paying once per year for initial value of this. So it's $163,302.49 currently. So now we're asking, how much are you going to have to pay each year to be able to purchase that car? So we're going to go over here. So the final value that you are looking to buy is that negative $163,302.49. With a rate of 10%, because you can invest 10% annually. And our number of periods is going to remain the same. You're still waiting 7 years because you're buying it on your 27th birthday. You are currently 20. So now we're calculating what is that payment. So we're going to put in our payment function. So 10%, 7 periods. Skip PV, FV. So we're looking at paying $17,212.98 per year. Prize of a trip across Europe in 1 year valued at $25,000. If instead you are able to take the present value of the trip in cash, how much cash would you want if the rate you can earn is to 8% annually compounded quarterly? So we're looking at what is that initial value. So final value is negative $25,000 as you are investing that, you're taking that rate, and your rate is going to be that 2% because it's annually but compounded quarterly, so it's 8 divided by 4, which is 2. So rate of 2%. And number of periods, as we said, it's compounded quarterly, so 4 periods. So that initial value equals PV, rate of 2% for 4 periods, $25,000. We're looking at $23,096.14. Present value of the following cash flow stream is $6,000 when discounted at 12% annually. That stream consists of payments made at the end of each of the 4 periods. One of the payments, the second one, is missing. The others are 1,000 at n equals 1, 2,000 at n equals 3, and 2,000 at n equals 4. What is the value of the missing cash flow? So we're going to set up a nice little chart with the cash flow, rate, an initial value, and we're going to go 0, 1, 2, 3, and 4. We're going to throw in 12% as our rate. Oop. That was $1,000 at 1, and then $2,000 at N3 and N4. All right. So now we need to calculate the PV amount. So equals PV, rate of 12%, 1 period, no payments, and negative 1,000. So $892.86. So now we're going to repeat the same process for 3 and 4. We're going to skip 2 because we don't have any values for 2, and that is what we are calculating. And the crucial part is that negative in front of the FV value of 2,000. $1,423.56. PV, 12%, 4 periods, negative 2,000. Perfect. So now we're going to be looking at the sum of 1, 3, and 4 and subtracting it from the total cash flow stream of $6,000. So total PV. So we're going to put that as 6,000. And then we're going to do equals sum of this one, this one, this one. Close our parentheses. Perfect. So we have $3,587.45. So we're going to calculate PV2, which is just equals minus. So it's $2,412.55. But we need to calculate what was that original amount. So of cash flow. So what we're going to do is equals FV, 12%, still the same, period 2, payment no. We're going to do a negative $2,412.55 for a total of $3,026.30. Company invests $2 million to clear land and plant pine trees. The trees will mature in 10 years, and the company expects to sell them for $6 million. What will be its annual rate of return on this investment? So this question is actually quite simple. So we're going to look at PV, FV, and number of periods to calculate the rate. So the initial value is investing $2 million, and because of the million portion, we're just going to drop that and use the 2 and the 6. So invest 2. So we're going to put -2 for a final value of $6 million, and we're just going to ignore the million, so 6. And the number of periods matures in 10 years, so 10. So equals rate of number of periods, no payments for the initial value. Ooh. Initial value of -2 for a final value of 6. 12%. Now I've been having issues with my Excel chart, so if you look here, it does say that the result is 11.61. I'm just having some issues trying to show that it is in fact that on my display. But all my calculations are correct. So it's 0.1161. In percentage, that's going to be 11.61%, and that is our answer. 6. After graduation, you decide that you can pay $203.24 per month extra on your student loan. So that means on top, you can pay an additional $203.24 on top of the standard $302.99, which has a balance of $50,000 and 20 years of monthly payments remaining. The annual interest rate on the loan is 4%, 4% compounding monthly. How many years early will you be able to pay off the loan? So first, let's look at the number of periods that you would be paying if you were to take on this new charge of $203.24 per month on top of the $302.99. So PV, that initial value, was going to be the balance. So $50,000. Rate is going to be 0.33% because it's that 4% compounded monthly. So 4 divided by 12 is approximately 0.33. And the payment is now $302.99 plus $203.24. So PMT is negative 506.23, as you will now be paying that amount. So now we're going to calculate the number of periods. So an n per function of 0.33, payment, PV. And so we are looking at about 120 periods. Gonna round up just because you're not gonna pay a fraction of a monthly amount. All right. So the next question is, how many years early will you be able to pay off the loan? So if you were not to take on this additional role, it's 20 years of monthly payments. So 20 equals 20 times 12. 240 is standard, let's call it. Now, if you spend extra, it's that 120 we just solved. So with some basic subtraction, the saved payments is equals minus, you're saving 120 payments, but that's payments monthly. So you're going to do divided by 12, you will be paying off your loans 10 years earlier or than expected. 7. The engineering staff at the Sun Shipping Company has informed decision makers that substantial money can be saved on the fleet's fuel bills if the ship's engines are adapted. Based on the cost of fuel, the engineers estimate that the firm will save $50,000 each year for the first 4 years and $75,000 per year for the following 6 years. If these estimates are correct, what would the company be willing to pay to adapt the engines? The company can earn 10% annually on all of its investments. So this is similar to a question that we had before, in that we're going to start off by making a cash flow table. So cash flow, rate, and that's 10% annually. And then we are going to calculate the PV. So for year 0 all the way to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and it says for the first 4 years, the firm will save $50,000. So years 1 through 4, we're going to put in $50,000 for cash flow. So and then for the next 6 years, they'll save $75,000. So, whoop. All right, so now we're going to calculate the PV equals PV, rate of 10%, 1 period, no payments, for a negative $50,000. So, got that one. Just going to keep repeating this for the next 4. Not few. Period, no payments, negative $50,000. And while there is a way to shorthand this to ensure that I don't do any calculations wrong on my part, like so, I am doing it all by hand. Oh, comma. Oh, we're going to want to delete that. Yep. See, stuff happens. All right, 10%. 3 periods, no payments, negative $50,000. That looks much nicer. 10%, 4 periods, whoop. No payments. We're in the home stretch here. PV, 10%, 8 periods, negative $7,000. All right, last one. 10%, 10 periods, $75,000. All right. So now what is the total PV? Because we're looking at what would the company be willing to pay to adapt the engines. All right, so equals sum 1. Yep. 2, 3, 4, 5, 6, 7, 8, 9, 10. So they will spend $381,595.90. Another super simple question. You've just purchased a share of preferred stock for $60. The preferred stock pays an annual dividend of $5.60 per share forever. What is the annual rate of return on your investment? So as we know, there is an equation, P equals D divided by R. So preferred stock equals dividend divided by rate. But if we move it around, we know that rate equals dividend divided by preferred stock. So P is 60. D is that 5.6. And R, our rate, equals 5.6 divided by 60. And then when we make that into a percent, that is 9.33%. Your 2-year-old son will be attending Harvard in 15 years, and you've determined that he will need $70,000 per year for tuition and living expenses. You want to give him a lump sum for the amount needed, assuming that he will be able to invest the money not yet needed at 5% interest. So monthly in order to do so, you will make monthly payments, and you found that your annual return of 7% on your monthly payments. So how much will you need to invest each month to give your son the money he needs for school? So we're going to start with a little chart. So amount, rate, and present value. And then we're also going to put the time. So 0, 1, 2, and 3 for his time at school, because we're starting with 0 as his freshman year. So he's going to need $70,000, $70,000, $70,000, and $70,000, as we determined that is the tuition and living expense per year. And that's at a rate of 5%. So now we need to calculate the PV. So I'm just going to keep doing this. All right, so now we need to figure out in total, what is the amount you're going to need to pay for his tuition. So total PV, we're going to do equals sum of all 4 years. Perfect. So now we need to figure out, what are your monthly payments going to look like in order to achieve this goal. So we're going to set your final value as that negative $260,000, $627.36. And our rate, as we saw, it is 7% per 12 months on your monthly payments. So equals 7% divided by 12. Number of periods, so as we said, it is going to be per month for the next 15 years. So 15 times 12 is 180. So let's calculate that payment amount. So equals PMT. Rate, 180 periods. Final value, you're going to need to make $822.27 per month payments. A friend calls you with a great investment opportunity that will produce the following set of cash flows: $2,000 a year for the 6 years starting at the end of the year 2 years from now, and $5,000 after that. Assuming you can invest in an investment of a similar risk elsewhere at an annual interest rate of 8%, what is the most that you should be willing to spend? So we're going to create a cash flows chart similar to ones that we've done before. So cash flows, rate, we're going to be calculating the PV. So 0, So it says 6 years starting at the end of 2 years from now. So 2 years and then an additional 6 years, we're looking at about 8 years. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And we are looking at a rate of 8%. Because it's saying, assume you can invest in an investment of similar risk elsewhere at an annual interest rate of 8%. So you're comparing it, saying, if we put this one at 8% as well, then what should I be willing to pay for this investment compared to a different one? So year 1, you're not going to make anything. Year 2, you'll make $2,000, and that's for the next 6 years. Then after that 6th year, you'll make $5,000. All right, so now we're going to calculate the PV. So, PV, rate of 8%, period 1. You've got nothing, so you're going to make nothing. So, let's do it again. Rate of 8%, second period, negative 2,000. All right. Another one. Period 3. Don't forget to add that negative to the FV amount. All right, last one. PV, 8% for 8 periods, negative 5,000. All right. So now we're looking at the total PV. What is the most that you should risk on this? So we're going to look at the sum. So sum 0. This, and also this. So, the most you should be willing to pay for this investment is $11,262.23. And that is all.